All right, guys, even more hypothesis testing, and be saying that for several days. So let's see what else we got. There's three types of tests with hypothesis testing. There's a two-tailed, a left-tailed, and a right-tailed. And I got pictures over here for you, and it's not hard to tell which kind you're going to use. If you have a not equal symbol with your alternative hypothesis, then you can have a two-tailed test. If you have a less than, it's exactly what you think. If your alternative hypothesis has a less than, it's going to be a left tail. And if your alternative hypothesis has a has a greater than, it's going to be a right tail. So your inequality sign actually points to what tail it's going to be. P-value method is a method we're going to use. There's actually two methods you could use. One's called critical value method. The other one is called the p-value. The p-value is what is used the most these days. So that's what we're going to use also. And plus, it's very easy to find the p-value using technology, so it's a great way to go. Basically, the p-value is a probability of getting a value of the test stat that is at least as extreme as the one representing the sample data. Assuming the null hypothesis is true, which we're going to keep that assumption. To find the p-value, you have to first find the area beyond the test statistic. That's in your picture. So if you have a curve such as a normal curve and your test statistic is right here, I don't know, let's say it's 1.6, and this part is the extreme part, that would be the right tail test, and it would be like, is the p-value in that region or not? And that's how you could tell. All right, just a quick flow chart on how we're going to roll here. To start, you got to figure out what type of test is it. Two-tailed, left-tailed, right-tailed. Let's go left-tailed first. If it's left-tailed, we're going to go down here and find the p-value. And there's your picture. Is the p-value? P-value is equal to the area of the left of the test stat. So if the p-value fits in there, then you would reject the null. If it is a right-tailed test, we would go this way. P-value is the area to the right of the test stat, and if it's in there, you would reject the null. And if it's not in there, by the way, you would fail to reject the null. If it's two-tailed, it could be either one. If it fits in either one, so what we do is we think about the p-value being twice the area of the left-hand side or twice the area on the right-hand side. Hope that made a little bit of sense, or it will. Hopefully by the end of the day tomorrow, after we work on some of these, it will make even more. All right. Word of caution, do not confuse the p-value with the population proportion p. They are two different things. What a p-value is, if you're still struggling a little bit, which is probably the case, and that's okay if you are, it's the probability of a test stat being at least as extreme as the one obtained. So it's the probability, it is all probability, it is not a proportion that is at least extreme as the one that you worked out when you did your test stat. P, remember little p is just population proportion. A quick example. This goes back to the problem we did even yesterday with the gender selection, and this says a test stat of z equals 1.60 as an area of 0.0548 to the right, so it's a right-tailed test with z equals 1.6. So this is what our null was yesterday. It was like, if you have a 50% chance of having a girl, so the probability of having a girl is 0.5. With the gender selection, they were trying to say that it's bigger than 0.5. And when we ran the test from that problem, we got a test statistic of 1.6, which is really their z-score. Obviously, it says z is 1.6. The area to the right of that z-score is 0.0548. And to be honest, since that is bigger than 0.05, we would actually reject the null in that case. We would fail to reject the null because the probability is too large. It's bigger than 0.05 and definitely bigger than 0.01. But that's what the picture looks like with an example. All right, deciding to reject or fail to reject the null. If the p-value is less than 0.05 or 0.01, whichever one you're using, we're going to reject the null. If it is greater than that, we're going to fail to reject the null, which is what was on the last slide. That's why we failed to reject that one. Restate the answer or restate the decision using simple non-technical terms. I've been making a big deal about that the last 2 days. Here's kind of how you do that. If your original claim does not include an equal sign and you reject the null, which, if it's like the last one, if it's greater than 0.5, and you reject the null, you would say there's sufficient evidence to support the claim that the gender selection method is effective. If the original claim does not include inequality, like if it does not have an equal sign, and you fail to reject the null, you say there is not sufficient evidence to support the claim that the gender selection is effective. Okay, if your original claim does have equals, which means your original claim is the null, and you reject the null, you would say there's sufficient evidence to warrant rejection of the claim that. And the last one, if your original claim contains equality, which again means it is the original claim is the null, and you fail to reject it, you would say there's not sufficient evidence to warrant rejection of the claim that the gender selection does work. All right, never conclude a hypothesis test with a statement of reject the null or fail to reject the null. You always need to write a sentence like I had on the last slide that makes a conclusion using simple, non-technical wording that addresses the original claim, whatever that claim may have been, whether it was the null or the alternative hypothesis. All right, last thing here. Types of errors. There are two types of errors. The type 1 error is when you mistakenly reject a null when it's actually true. And that's going to happen sometimes because we're using probability. Type 2 error is the mistake of failing to reject the null when it's actually false. And I got a little chart down there at the bottom. You can kind of see that, but that's exactly what it says. If the null hypothesis is true, if it's true and you fail to reject it, you made the correct decision. If no hypothesis is false and you reject it, you made the correct decision. If you reject a true null, you made a type 1 error. If you fail to reject a false null, you made a type 2 error. Let me show you a quick example for the last slide on the video. All right, example, consider the claim, the same thing, that a method of gender selection increases the likelihood of a baby girl so that the probability of a baby girl is greater than 0.5. In that case, the null is 0.5. Now, this is our claim. That's the claim. So the claim is actually the alternative hypothesis. And what would the type 1 error look like? Well, the type 1 error would be, the type 1 error, remember, is when you reject the null when it is true. So if I did that, if I did reject that null and it was true, what I would be saying then is I would conclude that the gender selection method is effective when in reality it's not. All right, so if I reject this, if I reject that, and it's really true, that means I saying that the new method is effective when it's really not. All right, a type 2 error, which means I am failing to reject a null. So I'm failing to reject this even though it's false. What I'll be doing then is to say the gender selection method has no effect when in reality it really does. So I hope you see the difference. Type 1, I would be saying the gender selection is effective when in reality it's not. And type 2, I'd be saying it's not effective when in likelihood it really is. And it's all about, did I reject the null when it was really true, or did I not reject the null and it was really false? So two types of errors. Hope that made a little bit of sense. We'll work on those tomorrow. Work on all this tomorrow, and actually for a long time. But hope to see you tomorrow and get some of these questions answered if you have any. And don't worry about it being hard at first, because this is hard for everybody at the beginning. So hang in there. We'll get it. I promise you, we're going to get it.